I'm Boris. I'm an engineer.
I'm Kat. I'm a product manager.
We love seeing what people build with Claude, especially with coding, and we want to make Claude better at coding for everyone. We built some tools, one of which we're sharing today. We're launching Claude Code as a research preview.
Anthropic has officially released their latest AI model, Claude 3.7 Sonnet. This model brings a lot to the table, and there's quite a bit to unpack. Unlike your typical large language model, LLM, Claude 3.7 Sonnet is a hybrid reasoning model. It offers impressive capabilities, especially when we look at the benchmarks it has surpassed. If you take a closer look at the details, you'll see that. Today, we're excited to announce Claude 3.7 Sonnet, our most advanced model yet, and the first hybrid reasoning model on the market. According to the details, Claude 3.7 Sonnet can provide near-instant responses, or, when needed, extended step-by-step reasoning that is fully visible to the user. API users also have precise control over how long the model can take to think through a response. Now, this hybrid reasoning is really interesting. It combines what's known as System 1 and System 2 thinking, which I'll explain in a moment. In simple terms, this means the model can generate answers tailored to both complex, thoughtful queries and quick, on-the-spot questions that demand immediate responses. They explain that the development of Claude 3.7 Sonnet was guided by a different philosophy compared to other reasoning models available today. Just as humans use a single brain to handle both quick reactions and deep reflection, we believe that reasoning should be an integrated capability in cutting-edge models, rather than requiring a separate system altogether. This unified approach not only enhances performance, but also provides a smoother, more seamless experience for users. They're essentially referring to the concept of System 1 and System 2 thinking. System 1 is all about intuition and instinct, where, like humans, large language models can provide instant responses. On the other hand, System 2 is slower and more logical. This is where you engage in deeper thought to solve more complex problems. And this is exactly the approach they've embedded into Claude 3.7 Sonnet, allowing it to handle both quick and thoughtful responses. With Claude 3.7 Sonnet, you now have the ability to control the thinking budget. If you're a developer, this means you can specify the maximum number of tokens the model can use when processing a task. You get to decide how long you want Claude to think. This feature is incredibly valuable because it gives you full control over the model's thought process. One issue I've noticed with other reasoning models is that they might only think for 10 seconds on a problem when you actually need them to take longer, maybe 100 or even 200 seconds. This level of customization is going to be a game changer. Before we dive into the infamous benchmarks, let's take a quick look at how Claude 3.7 compares to Claude 3.5. Claude 3.7 is significantly smarter than its predecessor, Claude 3.6. With this version, you can enable the extended thinking mode, where the model self-reflects before answering. This feature greatly enhances its performance, especially in areas like math, physics, instruction following, coding, and many other tasks. The good news is that prompting works similarly in both modes. So if you have prompts that worked well with Claude 3.6 Sonnet, they're likely to work just as smoothly with Claude 3.7, with no changes needed. One of the key aspects that sets Claude 3.7 apart is its focus on real-world applications. The team behind it explains that in developing their reasoning models, they've placed less emphasis on math and computer science competition problems, and instead shifted their focus to tasks that reflect how businesses actually use language models. This is a game changer because too often companies get caught up in optimizing for benchmarks that aren't necessarily practical for everyday use. For example, when we look at the benchmarks for Claude 3.7, you'll see that they're still impressive, but many of those benchmarks don't directly translate into value for the average user or business. This focus on real-world utility is one reason why Claude 3.7 and 3.6 have generally outperformed competitors like ChatGPT. They've trained their models to excel in practical, everyday scenarios, rather than just aiming for high scores in niche competition problems. Now, let's take a look at the benchmarks for Claude 3.7 Sonnet. One thing that stands out is that while Claude 3.7 doesn't necessarily dominate all other models in every benchmark, it does show strong performance in key areas. For example, the recent release of the Grok 3 beta showed some impressive results, but Claude 3.7 Sonnet manages to edge it out in several important benchmarks, like agentic coding and agentic tool use. These are the types of tasks that are directly relevant to real-world applications, and it's great to see Claude 3.7 excelling in them. However, in areas like visual reasoning and high school-level competition math, we're seeing top models like Claude 3.7, Grok 3 beta, and others converge around similar performance levels, around 86%. But in the GPQA benchmark, Claude 3.7 Sonnet does pull ahead. What's interesting about Claude 3.7 Sonnet is that it's a model that's difficult to fully assess just by looking at benchmarks. It's one you really have to use in practice to appreciate its full capabilities. From what I'm seeing in the AI community, it's clear that many people are excited about this model, and I wouldn't be surprised if Claude experiences a huge spike in usage. In fact, I expect it might even run out of inference capacity, considering how many users are already jumping on board with the previous versions. But as I mentioned earlier, while the benchmarks are important, there's one key benchmark we need to focus on. The benchmark we're focusing on here is agentic tool use, which is incredibly important because it evaluates how AI agents handle real-world tasks involving user and tool interactions. This is a benchmark designed for practical, real-world usage, and it's crucial for assessing how well AI can be applied outside of just competition settings. Essentially, this benchmark measures how consistently an AI agent can perform the same task across multiple trials, using a metric called pass at K, which tracks reliability over repeated attempts. This is important because while benchmarks like competition math and GPQA are great for gauging an AI's intelligence, real-world use cases require AI to perform reliably and consistently in a variety of situations. Focusing on tool use, as this benchmark does, ensures that AI agents are prepared for deployment in sensitive, real-world environments, like customer service or healthcare, where consistency and reliability are absolutely vital. And of course, it wouldn't be a proper benchmark discussion without mentioning SWE Bench Verified. This benchmark, specifically designed for the software development niche, shows that Claude 3.7 Sonnet has achieved state-of-the-art performance. The fact that it's performing at this level really highlights just how much better this model is compared to OpenAI's GPT-3. We can clearly see that, while there's been a lot of hype surrounding GPT-3 and DeepMind's models, Claude 3.7 Sonnet has managed to outperform them by a significant margin. What's even more interesting is that this isn't just about the benchmarks. It's something I've seen firsthand. Developers who are currently coding with Claude 3.7 Sonnet are saying that this model is absolutely outstanding. For example, while OpenAI's GPT-3 scored around 49% and GPT-1 around 48%, Claude 3.7 Sonnet made a massive jump, scoring 62.3%. With custom scaffolding, it even reached 70.3%. This is a huge leap, nearly a 12% increase in just 4 months, from October 2024 to now. While that might not sound like much at first, when you consider its impact on day-to-day use, it's a major upgrade for real-world software development tasks. For those of you who use DevOps, you'll notice that in the agentic coding evaluation, Claude 3.7 Sonnet once again shows impressive results, jumping up to 67%. This just reinforces the trend we're seeing. GPT-4 started at 49%, and now Claude 3.7 Sonnet has already reached 67%. It really makes you think, just imagine where we'll be in a few years. The future is incredibly exciting. If you're curious about Claude's coding capabilities, you'll definitely want to check this out. There's a new agentic coding tool that lets users interact with Claude directly in the terminal. This tool has been launched as a research preview to enhance the coding capabilities and features of Claude 3.7. What makes this tool so powerful is that it can understand your code base, analyze repositories, and provide insights into their structure. Users can request changes, view Claude's thought process, and even generate and execute tests. It can automatically resolve errors, detect and fix build issues iteratively, and push changes to GitHub with clear summaries. If you're someone who uses Claude for coding, This is definitely a video you'll want to watch.
Should we be doing like big smile or?
No, what are you doing? Big smile's
Okay.
creepy.
That's sort of what I think. I'm Boris. I'm an engineer.
I'm Kat. I'm a product manager.
We love seeing what people build with Claude, especially with coding, and we want to make Claude better at coding for everyone. We built some tools, one of which we're sharing today. We're launching Claude Code as a research preview. Claude Code is an agentic coding tool that lets you work with Claude directly in your terminal. We're going to show you an example of it in action.
So we have a project here. It's a Next.js app. Let's open it up in an instance of Claude Code. Now that we've done this, Claude Code has access to all of the files in this repository. We don't know much about this codebase. It looks like an app for chatting with a customer support agent. Let's get Claude to help explain this codebase to us. Claude starts by reading the higher level files, and then it dives in deeper. Now it's going through all the components in the project. Cool. Here's its final analysis.
So say I was asked to replace this left sidebar with a chat history, and I'm also going to add a new chat button. I'm going to ask Claude to help me out here. We haven't specified any files or paths, and Claude's already finding the right files to update by itself. Claude can also show its thinking, and we can see how it's decided to tackle this problem. Claude's asking me if I want to accept these changes. I'll say yeah. Now Claude's updating the navbar, adding a button and icons as well. Next, it's updating the logic to ensure the saving state works correctly. After a bit, Claude completes the task. Here's a summary of what it's done. Let's take a look at the app. So we're seeing a new chat button and new chat history section on the left. Let's check if I can start a new chat while keeping the previous one saved. I'll try out the new chat button too. Great, it's all working.
Now let's ask Claude to add some tests to make sure that the features we just added work. Claude's asking for permission to run commands. We'll say yes. Claude is making some changes to run these tests. After getting the results, it continues with its plan until all tests pass. After a few minutes, it looks like we're good to go. Now I'm going to ask Claude to compile the app and see if we get any build errors. Let's see what it finds. Claude identified the build errors and is now fixing them. Then it tries to build again. It'll keep going until it works.
Now let's finish everything up by asking Claude to commit its changes and push them to GitHub. Claude creates a summary and a description of our changes. And it'll push the changes to GitHub. That's it. That's an example of what Claude Code can do. We can't wait for people to start building with it.